Hello students, welcome to our AriserTalent. I am your maths faculty Arpita Sharma. Students, we are going to start a new chapter today. Okay, the previous chapter that we have studied is what? Trigonometry, and the second part is here, which is what? Nothing but application of trigonometry. Right students? Now in trigonometry, we have studied the ratios, some formulas, okay, relations between different trigonometric ratios, we have studied about it. Now we will be studying application part of trigonometry. As you all remember, in the first lecture of my previous chapter, I've told you that this trigonometry is like a magic, and it's very helpful when it comes to your day-to-day life, your problems related to day-to-day life, the measurements, you will be solving it like this. Okay, so how's possible the application part is here in this chapter? Okay students, so before going through the angle of elevation and angle of depression, let me recall you something, that what we have studied was sine, cosine, tangent, cotangent, secant and cosecant. Now in these, from following these, I want you to remember, then when we were discussing theta, I am telling you about these three. We will be having the proportions of this will be P by H, B by H and P by B. We also made a trick like this, which we call Pandit Badri Prasad Har Har Bole. Okay, so this is how we reminded, and this will be inverse of this B by P. This will be inverse of cosine, so H by B, and this will be H by P. Okay, and these all ratios came from here, from a right angle triangle. Okay, right? Suppose this theta, that was your perpendicular, that was your base. Base of theta is base, okay. That was your hypotenuse, and the story goes on. Okay, now how we will use it? I've told you, note it. I've told you in my first lecture of the previous chapter that suppose you're having a building here, and in something like here you are sitting, and I just magnified that particular area and draw your eye here. Okay, now if this is your eye, you can see what? If this is the horizon line, then you can see upside, you can see downside. Let's have another building here. Okay, so you can see the top of that building, or let's suppose here's no building. So there are two cases, you are looking upwards or you are looking downwards. Somehow we were having some beautiful water lake here around there, and we was unknown of this length, right? And we somehow traced a flower here, okay, and just by knowing this angle, that from what angle you were looking at it and from what height you were looking at it, you will able to find out what? The width, right? We were talking about this, है ना? Okay, so what we observe from this, that if this is our horizon, this is our horizon, okay, the line perpendicular, the line parallel to the earth surface, this is our horizon. I can either look up, okay, and look at anything, or I can look downward and look at anything. Like I am looking at it, okay, the first thing, and I am looking at it, the second case, the downward side and the upward side. Okay, students, right? So what are these cases will be called, and how will I be able to find it? It is very interesting, students, that we know the distance from the earth to particular star or to sun. Okay, we are not able to go there and have a measuring tape and measure it like this. So how it's possible to measure them? Okay, when you talk about universe, and you talk about stars, and you talk about the universal heavenly bodies, then talking about their distance, their measurement is out of context. If you use that measure tape, it's not possible to have measure tape in your hand and go there. It's actually not possible, right? So in that thing we use some formulas. Okay, so this is the basis of all these things, right, students? Okay, so now I'll be telling you what these angles are called. Okay, so the first angle of elevation. Now do one thing, that I'm making something here. I'm making a hot air balloon here. Okay, this is a balloon, and you are sighting it from here, and there is a flower, and you are sighting it from there. Now this is some angle, right? And this is some angle. This is your horizon. Okay. So if I see upside, I'll call it angle of elevation, and if I am sighting downward, so I'll call it angle of depression. It's so simple, student, actually, but we'll just make that thing in our language like this. Okay, so here angle of elevation, the angle of elevation of the point viewed is the angle formed by the line of sight. The line of sight that was with the horizon when the point being viewed is above the horizon. Okay, above the horizontal level, that is the case we raise our head, okay, to look at the object. If I have to look at this. So what will I do? This? No, this. So if I'm keeping this here, and I'm looking like I'm keeping my head up to the upside. So what will it be? Angle of elevation, right? Okay. So it's saying that the line of sight with the horizon when the point being viewed is above the horizontal level. That is the case when we raise our head to look at the object, like this. This was the angle of elevation theta. If this is the line of origin, then this is the angle theta. So come here, this side. If this is the line of origin, this angle will be what? Angle of what? Elevation, right, students? Now the second one. Okay, the second one is angle of depression. The next case, the second case, when that was like here and I was sighting it, my eyes, either my eyes or head are like bending downwards. Okay, now the angle of depression of a point of the object being viewed is the angle formed by the line of sight, okay, with the horizontal line of sight, that side with the horizontal when the point is below the horizontal level. That is the case when we lower her head to look at the point being viewed. Okay. So, this is the case angle of depression. Horizontal angle is this. I have told you. If I will talk about this here. This will be what? This is the horizontal line. Now, I am looking downwards at this flower. So, this angle will be what? Angle of depression. Right, students? So, is it clear to you or not? Okay. Let me clear this. Now, students, in this triangle, this is the horizontal line, this is also horizontal line. If you look at these particular two parallel lines and the line passing through that, so this angle will be equals to what? This angle. So, angle of elevation from point C will be equals to angle of depression from point A. So, this terminology is also of use, that you also have to remember that the angle of elevation at the point C is equals to what? Exactly the angle of depression from point A. We can use this, right? Now, next is what? Next is the question. Question based on the same thing we were studying. So, here is the shadow of a building is 20 meter long. Now, the shadow of a building, talking about a beautiful building here. Let's assume it's beautiful. Okay. And we are having some floors on it. Right. Okay. Now, it's not talking about the height of this building, but saying that the shadow of a building is 20 meter long when the angle of elevation of the sun is 60 degree. So, I'm talking about this ground, right? Now, I'm citing this, right? Now, this angle of elevation is what? 60 degree, right? And this shadow is what? It's given that it's 20 meter long. Okay, find the height of the building. What is the height? This is only a diagram I have drawn to actually feel you how the condition is. Okay, so you need not to mention this building like this in your exams. You just have to view it so that you can understand in the question number 1 only. Okay. In other questions, we will just drawing a line. I will assume that is building, this is road, and this is what, and this is what. So, here is the thing. Okay. Now, I have to find this height. Now, this height will be equal to this height. So, I have to actually find this length. Now, students, if I consider this point as A, this point as A, this point as B, and this point as C. Is it a ABC right angle triangle? Okay, whose right angle is at B? So, can I apply the trigonometric ratios we have studied so far? Okay, and we have also studied some specific ratios value like 60 degree, 45 degree, 30 degree, 0 degree, 90 degree of tan, sine, cos, sec, cosec, cot, right? Okay. So, we are going to do this only. So, the solution of this question is that will be exactly the diagram you will be making in your exam copies. That will be 20 meter. Okay. That will be 60 degree, and that will be height of building. Let's suppose h or mark it small h, otherwise you will be confusing it with hypotenuse. Okay. So now it's A, it's B and it's C. Now given shadow length or length of shadow equals to what? 20 meter, right? That is, you can say, equals to BC in the figure. Now students, angle of elevation is equals to 60 degree. I have to find H or I have to find AB. Now look at this, I have given BC and I have to tell that what is AB. Now what is the relation between AB and BC when it comes to trigonometric ratio? Perpendicular and base. That will give you the ratio of what? Ratio of tan of theta, right? So tan theta equals to what? P by H, sorry, P by B. This implies that what? Tan, what is this? 60 degree will be equals to perpendicular. Now what is perpendicular? This is the angle, this is the base and this is the perpendicular. So it will be H upon BC, that will be 20 meter. Okay. Now value of 60 degree, tan 60 degree, I have told you 0, 1 by 2, 1 by root 2, root 3 by 2 and 1. Cos value 1, root 3 by 2, 1 by 2 and 0. Now this was 0, 30, 45, 60, 90. Now the complete all values you can easily find from here. Now you have to find 60's value. Now 60 root 3 by 2 divided by 1 by 2 will be giving you what? Only root 3. Okay. So tan 60 degree will be what? Root 3. Okay. So root 3 equals to H by 20 meter. This implies that what? H equals to 20 root 3 meters. That's your answer. On the maximum, what you can do, you can just put the value of root 3 and solve it. Okay, you can do this thing if you want to go further for your answer. So student, this is a simple question. You just applied the angle of elevation here and applied trigonometric ratio here and the answer is in front of you. Okay. So this is the one thing. Okay. What will be happening in this chapter? As you go a little bit higher in your chapter, you'll see that only it's being more tricky. You have to find what is the angle of depression, what is the angle of elevation, and you have to just draw a picture and you will just start using the trigonometric ratios. The sum will be there. Okay. So the next question is a ladder. Okay, a ladder against a vertical wall makes an angle of 45 degree with the ground. The foot of the ladder is 3 meter from the wall. Find the length of the ladder. Okay. What's saying that this is your ladder and this is your wall. It looks like a wall actually. Okay. So it's saying that this is your wall and here's your ladder. Now it's telling you to find the length of ladder. Okay, it's telling you that from your ground, this is your ground, from your ground, it is at a distance of this distance is given. Okay, so you have to find the length of this ladder, right? Now, how will you imagine this thing? This is your let's suppose wall, okay, and that wall you're having this is your wall somehow, okay, this is your wall and you're having your ladder here like that, okay. Now this is given that the foot of the ladder is 3 meter from the wall, 3 meter, okay, and the ladder is a vertical wall makes an angle of 45 degree with the ground. With the ground it makes 45 degrees, okay. Find the length of the ladder. Length of the ladder will be what? Again, the wall will be straight. If wall will be straight, then there will be an angle made up of, there is a triangle made up of angle 90 degree. So, right angle triangle, we can apply easily the trigonometric ratios, okay. So, what will I do? I will just be doing this thing, that solution is here. I have to find this hypotenuse when I have given with the base. So, base and hypotenuse. Base and hypotenuse is giving you what? Cos of theta. Okay. So, we'll be writing that given all these things, angle of elevation 45 degree, the foot of ladder from wall is 3 meter. Okay. So, by applying this thing, we'll be writing what? Cos theta by trigonometric ratios, cos theta equals to B by H. Now, B is equals to what? Put it A, B and C. Now, base is what? BC, right? And hypotenuse is what? AC. Okay, that implies cos of 45 degree. Cos of 45 degree equals to what? 1 by root 2. And BC you have given with 3 meters, you have to find AC, okay. So, it will be 1 by root 2, 3 meters by AC. So, from here you can easily find that S equals to what? 3 by root 2 meters, okay. So, this will be what? Your answer. Isn't it so simple? Note it out. Okay, students. And one thing more, that will be AC here and root 2 here. So, root 2 will be going there only. Okay. It will be like this. AC here and 3 multiplied by root 2 here. So, it will be your answer. Right, students? Okay. I am rubbing this one. Now, students, about the next question. Now, in the next question, what we'll be doing? We'll be only understanding the pattern over here, that what the question want to say, and we'll draw a diagram and you will yourself be doing this thing. Okay. What this question is saying is, from the top of a building 30 meter high, the top and bottom of a tower are observed to have angles of depression 30 degree and 45 degree respectively. Now, it's talking about two depression angles in a particular question, and it's giving that the height of a tower is, it's asking about the height of tower, and it's saying that the top of building is 30 meter high and it's given with the two depression angle. Now what? Is it tricky? It's nothing like tricky. Just look here. From the top of a building 30 meter high. Okay. So, we have given a building. This is a building which is 30 meter high. Try to just, have your pencil, have your pen in your hand and just draw diagrams as the question is saying. 30-meter high, the top and bottom of a tower. So, of a tower, it's talking about another tower, not the building. Okay, so I can make it here also, I can make it here also. So, it will be, you know, some like merged in between these things. So, I am drawing it here, a tower here on the ground only. So, if this is the ground, if this is the ground, it will be what? Here. So, the top and bottom of a tower, top and bottom, are observed to have angles of depression. Angles of depression 30 degree and 45 degree. Now, if someone citing this, someone at the top is citing this. This is what? Top of the tower. I can write it also here. Top of the tower. This is what? Bottom of the tower. Bottom of the tower. Right. Now, this is our building. And this is obviously our tower. Now, this top and this bottom. So, the angle of depression will be like this. Angle of depression. Okay, like you are here standing here at the top of the building and you are sighting the bottom of the tower. Now, what it's saying, that depression angle. This is the angle of, this is the line of origin. Okay, so first angle is this and the second angle is this. First angle from for the top, it's saying that it's 30 degree, and what's for the second, it's mentioning the 45 degree. Now, if it's the 30 degree, if I draw a line here, okay, so if it is 30 degree, so it will be also what? 30 degree. And now as it is 45 degree, this will be also what? 45 degree. Okay, so actually we have here a figure right, students? We are having a figure in which we are having this triangle. Okay, I am marking these triangles for you. This triangle is one. This is the triangle number 1. Okay, now I am having another triangle, triangle number 2. Right, I am having 2 triangles here, and I have to find out this. Now, if I mark this A, B, C, D, E, and let's mark it F. So, I am having triangle. So, I am having the triangles A, B, C and triangle A, D, E. Right, students? Now, in these 2 triangles, if I somehow find this height dB, then this dB will be equals to what? This EC. You can say these are 2 parallel lines and this is a rectangle. So, these DB and EC will be equal. So, what I have to do? I have to take care of this triangle and I am known with this side. So, I will be going to find this side. Now, after finding this side will be equals to what? This side BC will be equals to what? DE. Then, after finding D, what will I do? I am finding DE. So, I can easily find this. if I now have the AD and also AB, I'm having AB and I'm also having AD. So by AB minus AD, I can find DB, which is equals to EC. Okay, I have to just focus on this procedure, students, right? So we will be dealing with this question in our next lecture, but you have to do what? You have to try it on your own, because it's very simple. After making this whole diagram, it's it's like this for you. Okay, so just try to solve this and we'll meet in the next lecture. Okay, till then, take care students. Bye.